In this video, we're asked to find the area enclosed by the equations x plus y squared equals 3 and 4x plus y squared equals 0. So I want to start by sketching graphs of these two equations. So I'll start with x plus y squared equals 3. I'm actually going to think about this as x equals minus y squared plus 3. I'm going to think about this as a function on y. Plug in a y, get out an x. So my domain and my range are in opposite places than they usually are, but I still know what this graph is going to do. Because whatever I know about functions that look like we're used to, still true about them. So when I look at x equals minus y squared plus 3, I know I'm going to be talking about a parabola. But instead of facing up or down, it's going to have to face right or left. All right, well, if that was just y squared plus 3, it would face off this way. So it's been reflected over. A plus 3 is going to move me this way on the x-axis. We could even think about plugging in some y values. So y equals 0, then x is equal to 3. All right, well, we can just keep plotting some points to make sure this really is a parabola. Y equals 1, and I get out a x equals 2. Y equals minus 1, I still get out that point, and this really is looking like a nice, happy parabola. All right, so I don't know, let's think about y equals 2. And if I plug that in, I'll get x equals minus 1. Minus 2, I get out that same value, and I see that nice parabolic shape. Just thinking about plotting points and things I already knew about functions, but kind of having to think about swapping x and y from what we usually think about. All right, let's do the same thing for the second equation. So x is equal to minus 1/4 y squared. Another parabola. Another parabola that's facing off the right-hand side here. So again, I want to think about plotting points, and this time if I let y equal 0, I get out x equals 0. So this one starts off at the origin. And I can continue to think about points. Since I know my parabola faces this way, I'm only choosing, I know I'll only have points over here, so I can kind of pick different y values. I could imagine plugging in a y equals 1, I'd get out a minus 1/4, so not too far. And same thing down here. I think we can kind of understand the symmetry going on. Let's see what happens at y equals 2. I get out a minus 1, and hey, that's nice. I just happen to have plotted points where these two things intersect. And now I even see the region enclosed by them. I see the actual area we've been asked to find. So we're looking for this area. All right, well, I can see why integrating with respect to x would be a bad idea. I'd need many different integrals to do it, because there's like a little wedge here where the red one's on the bottom and the blue one's on top, and a separate one down here where the red one's on top and the blue one's on the bottom. Two halves of the blue one, right? I'd have to have many functions, right? 1, 2, 3, 4 functions in play, and at least 3 different integrals. But if I think about these as functions on y, there is one function on the right-hand side and one function on the left-hand side. We'll be able to do this in one definite integral. All right, because we happen to know where these intersections were, we know we're integrating from minus 2 to positive 2, and I need to take my right function and subtract my left function. So minus y squared plus 3 minus a negative 1/4 y squared. All right, so that's the integral we need to evaluate. So what I'm going to do is I'm going to rewrite it here, but I'm going to go on and change this minus a minus 1/4 to a plus. Now what I can do is actually simplify the integrand just a little bit, because I have a like term here. I'm going to throw in a missing parenthesis. Minus y squared plus 1/4 y squared would give me a minus 3/4 y squared plus 3. And now we can find our antiderivative. So I'd have that minus 3/4 and then a y cubed. I need to divide by 3. So that's just going to be a minus 1/4 out front. Plus 3y evaluated from minus 2 to positive 2. All right, so let's see. I can plug in a 2, I'd get 8 times a minus 1/4 is minus 2. Plus 6 minus, now let's plug in that minus 2, and I get a minus 8 times minus 1/4 is a positive 2. Minus 6. All right, so let's see, that's a 4 minus a minus 4. That total shaded area was 8 square units. And we have found the shaded area requested.